Beneath more than 2 miles of solid ice, scientists have just found something so massive, so strange, and so unexpected that researchers are calling it one of the largest hidden geological structures ever discovered on Earth. And it could completely rewrite what we thought we knew about our planet's past. For decades, most people pictured Antarctica as nothing but endless white ice stretching in every direction, frozen, empty, and largely a mystery. But underneath that ice sheet lies an entirely different world, one that has just revealed a secret so enormous, it is described as continental in scale all by itself. Let's start with what scientists actually found, because the scale of this discovery is genuinely hard to wrap your head around. An international team of researchers, led by geophysicists from the University of Genoa working alongside scientists from Durham University in Cambridge, identified a colossal, fan-shaped geological structure buried beneath the East Antarctic ice sheet. This isn't a single basin or a small pocket hidden under the ice. It's an interconnected network of roughly 30 giant subglacial basins, all fanning outward from a common central point, forming a single unified structure that researchers have named the East Antarctic Fan-Shaped Basin Province. To put that into perspective, this newly recognized formation incorporates some of Antarctica's most famous subglacial features, including the massive Wilkes Basin, the Aurora Basin, and even the basin containing Lake Vostok, the largest known subglacial lake on the entire planet. Here's what makes this discovery so shocking to the scientific community. Researchers have actually studied these individual basins for years. Wilkes, Aurora, and Vostok have all appeared in scientific papers before, treated as separate, unrelated features scattered across the frozen continent. What nobody realized until now is that these basins are not isolated at all. They are connected pieces of one single massive geological structure that spans an enormous portion of East Antarctica. It's the geological equivalent of studying individual puzzle pieces for decades without ever realizing they all belong to the exact same picture. So how did scientists finally figure this out, especially when more than 99% of Antarctica's actual bedrock is completely hidden beneath thick, unmoving ice? The answer lies in an incredibly clever combination of different data sources layered together. Researchers combined subglacial topography mapping, gravity measurements, magnetic field data, seismic readings, and detailed geological observations, essentially building a composite picture of what lies beneath the ice without ever having to drill through it. One particularly fascinating technique involved calculating something called isostatic rebound. Antarctica currently holds an estimated 27 million cubic kilometers of ice, and all that mass is so heavy it actually pushes the bedrock underneath it downward. If that ice sheet disappeared, scientists calculate that the land underneath would spring back upward by as much as a full kilometer, by reconstructing what the landscape would look like without the weight of the ice pressing down on it. Researchers were able to see the true underlying shape of the terrain, and that's when the fan pattern became impossible to ignore. Once they had that reconstructed topography in front of them, researchers noticed something they weren't originally looking for. Instead of random scattered depressions carved out by unrelated geological events, the major basins across this entire region shared the exact same underlying geometry, fanning outward from a shared central point positioned near the South Pole. Scientists describe this as a coherent, continent-scale radial pattern, something that simply doesn't happen by accident. The leading explanation researchers have proposed is a process called distributed rotational extension. Imagine holding your hand flat, with your fingers together and then slowly spreading them apart while keeping the base of your palm fixed in place. As your fingers separate, triangular gaps open up between them. That's essentially what scientists believe happened to the continental crust in this region of Antarctica millions of years ago, as it stretched and rotated outward from a fixed central point, opening up these enormous fan-shaped basins in the spaces between what became mountain ranges and ridges. Now, why does any of this actually matter beyond being an incredible geological puzzle? This is where the discovery starts to genuinely rewrite our understanding of how the entire Antarctic system works, both in the deep past and right now in the present. The underlying geology of a region directly shapes how glaciers and ice streams behave as they flow and eventually melt. Basins, ridges, and mountain ranges hidden beneath the ice act like a hidden skeleton, guiding where meltwater accumulates, where subglacial lakes form, and which pathways ice is most likely to follow as it moves toward the coast. Understanding that hidden skeleton in far greater detail than ever before gives scientists a dramatically improved ability to predict how vulnerable different regions of the East Antarctic ice sheet actually are to melting as global temperatures continue to rise. And this connects to something researchers have been racing to understand for years, because not all of Antarctica's ice is equally at risk. Some regions have already shown alarmingly fast rates of ice loss, and scientists have discovered that the hidden geology beneath these vulnerable zones plays a much bigger role than previously assumed. In a separate but related area of research, scientists studying strange pink rocks scattered near Pine Island Glacier, one of the fastest melting glaciers on the entire continent, were able to trace those rocks back to their geological origin using dating techniques combined with gravity surveys. What they found didn't just solve a decades-old mystery about where the rocks came from. It revealed crucial new information about how ice in that region flowed in the ancient past and how it's likely to behave as conditions continue changing. Researchers have also identified significant geothermal heat rising from deep beneath the Thwaites Glacier ice stream, another factor that can dramatically influence how quickly ice melts from below, completely independent of surface temperatures. This is exactly why the newly discovered fan-shaped basin province is such a big deal. It's not simply an interesting fact about ancient geology. It fundamentally changes how scientists model the future of the Antarctic ice sheet and, by extension, how accurately they can predict global sea level rise. Antarctica holds an almost unimaginable amount of frozen water, enough that if the entire ice sheet were to melt, global sea levels would rise by tens of meters. Even relatively small changes in how quickly ice flows toward the coast and vulnerable regions can have massive consequences for coastal cities and low-lying regions around the entire planet. Every piece of hidden geology scientists uncover, like this newly mapped basin province, gets fed directly into the climate models researchers use to forecast exactly how fast and from where that ice loss is likely to accelerate in the coming decades. If discoveries like this genuinely blow your mind, make sure you like this video and subscribe, because we cover the biggest science breakthroughs as they happen, long before most people ever hear about them. This isn't actually the first time hidden secrets have emerged from beneath Antarctica's ice in recent years, and each one adds another piece to an increasingly fascinating puzzle about the continent's ancient past. Separate research teams using radar have uncovered vast ancient river landscapes buried beneath the East Antarctic ice sheet, flat surfaces formed more than 80 million years ago, long before Antarctica ever froze over and became the icy wasteland we know today. Back then, this frozen continent looked completely different, with flowing rivers carving channels through a landscape that would eventually be buried under kilometers of ice as the climate cooled dramatically over tens of millions of years. Scientists have also mapped an enormous gravity anomaly hidden beneath Antarctica, a mysterious concentration of dense material deep underground that appears to be getting stronger over time, adding yet another layer of mystery to what's really happening far beneath the surface. Even more remarkably, when a massive chunk of ice, roughly the size of a major city, broke away from an ice shelf in West Antarctica a few years ago, it exposed a section of seafloor that had been sealed off from sunlight and human observation for potentially hundreds of years. Researchers who rushed to the newly exposed area aboard a research vessel discovered a thriving, never-before-seen ecosystem living in complete darkness beneath the ice, a stark reminder that Antarctica isn't just a frozen slab of rock in geology. It's also home to entire biological worlds that have evolved in near total isolation from the rest of the planet. Taken together, these discoveries paint a picture of a continent that is nowhere near as fully understood as most people assume, one that continues to reveal ancient rivers, hidden ecosystems, mysterious gravitational anomalies, and now an entire continental scale tectonic structure, all buried beneath a landscape most of us picture as simply flat, white, and empty. What makes the newly discovered fan-shaped basin province particularly significant compared to these other findings is the sheer scale of what it reveals about Antarctica's deep geological history, stretching back long before the ice ever existed at all. Understanding how the continental crust in this region stretched and rotated millions of years ago doesn't just satisfy scientific curiosity, it directly reshapes how researchers understand the fundamental architecture of the entire East Antarctic continent. Information that becomes increasingly critical as warming oceans and rising air temperatures continue to test the stability of ice sheets sitting directly on top of this newly mapped terrain. Every mountain range, every basin, and every hidden ridge uncovered through this kind of research becomes another data point feeding into the increasingly detailed climate models scientists rely on to forecast how our planet's oceans will change in the decades ahead. We tend to assume that in the 21st century, with satellites constantly orbiting the planet and advanced technology, mapping nearly everything, there can't possibly be major geographic secrets left to uncover. This discovery proves that assumption completely wrong. An entire continental-scale geological structure, larger than many countries, sat hidden and unrecognized directly beneath scientists studying Antarctica for decades, simply because nobody had connected the dots between these separately studied basins until now. Lead researchers involved in the that uncertainty is actually part of what makes this such an exciting area of ongoing research. Scientists suspect the fan-shaped basin province could represent a single massive tectonic event, or it might actually be the result of multiple separate episodes of Crustal extension that happened at different points in Antarctica's ancient history, layered on top of each other over millions of years in ways that are still difficult to fully untangle. Future. Research expeditions and increasingly sophisticated mapping technology, including next-generation ice-penetrating radar and satellite gravity missions, are expected to help refine exactly how this incredible structure came to exist, and what other secrets might still be hiding in the roughly 99% of Antarctic bedrock that remains completely obscured beneath the ice. Each new expedition adds another layer of detail to a picture that scientists are only just beginning to fully piece together, and researchers involved in this discovery have already indicated that follow-up studies are planned to pin down the precise age and formation history of the Basin province with far greater accuracy. Antarctica remains one of the last true frontiers left on planet Earth, a place where entire geological worlds can apparently stay, hidden in plain sight for generations before anyone realizes what they're actually looking at. This latest discovery is a powerful reminder that even in an age of satellites, supercomputers, and constant global surveillance, our own planet is still capable of surprising us in enormous, almost unbelievable ways. Scientists have spent decades studying this frozen continent piece by piece, and it took connecting data from radar, gravity, magnetics, and seismic surveys all at once to finally reveal a structure that had been hiding in plain sight the entire time. As researchers continue piecing together the hidden landscape buried beneath the ice, each new discovery brings us closer to understanding not just Antarctica's ancient past, but the future of our rising oceans as well. And if you want to be among the first to know the next time scientists uncover something this extraordinary, subscribe now so you never miss an update.